Now let's talk a little more about JVM. JVM or Java Virtual Machine reads and executes compiled bytecodes which are platform independent. You might be thinking what bytecodes are. The compiled Java codes are called bytecodes. If you have worked on languages such as C or C++, you might have noticed that on compilation they generate a .exe file. The .exe file contains executable codes which can be directly executed on a given operating system. These codes may not be executed on other operating systems. However, bytecodes may be executed on other operating systems provided the Java Virtual Machine is installed and configured. Java Virtual Machine is platform dependent and provides hardware platform specifications. This implies that though bytecodes are platform independent, Java Virtual Machines are platform dependent. Let me explain this point with a simpler example. Let's consider an international conference attended by representatives representing countries like Italy, France, Germany, Russia, and America. Let's consider English as an official language for communication. The representatives from countries like Italy, Germany, France, and Russia do not understand English and therefore have appointed translators. Let's consider a situation where each translator can only understand one other language apart from English. This means that each representative would need one translator. Now let's map this scenario to Java. Interpret the representatives as platforms, translators as Java Virtual Machines, English as bytecodes. This is what JVM and Java Platform Independence all about. Java Virtual Machine is implemented as a software. It does not include any hardware components. However, minimum hardware requirements are essential. JVM is implemented in a Java Technology Development Tool or a web browser. You may find a version of JVM installed in your web browser. Here you see the JVM installed. Java Virtual Machine facilitates garbage collection and exception handling. In most languages such as C, C++, and VC++, the programmer needs to explicitly manage the memory. That is, the memory allocation and deallocation is programmer's responsibility. Coming to Java, it is taken care by a component called as garbage collection. The component garbage collection is a part of Java Virtual Machine. Exception handling. Exceptions in Java are similar to exceptions in most other languages. Exceptions are used to handle abnormal program behaviors. The JVM can handle exceptions which are unhandled by a programmer. JVM provides definitions for the instruction set, class file format, stack, garbage collection, and memory management. Java development and execution infrastructure. In this slide, you will see what happens when a Java program is compiled and executed. Here I have a simple source file foo.java, which contains class foo. Let's give foo.java as an input to the compiler. The compiler checks for syntactical errors and if no errors generates foo.class which contains the bytecodes. As discussed, bytecodes are platform independent, which implies that they can be provided as input to any Java virtual machine irrespective of their platforms. In this slide, you can see 3 Java virtual machines running on Linux, Macintosh and Windows. Upon executing these bytecodes, the result expected is the same. However, their execution speed may vary. Java compiler. The Java compiler translates the Java programs into Java class files, which contain the bytecodes. The Java compiler also performs strong type checking and prevents access violations. What is strong type checking? In languages such as C and C++, you are allowed to assign a value of double or float to an int variable, which could result in a loss of precision. Java compiler does not allow such an assignment. In short, the process of ensuring assignment of a given value or reference to an appropriate type is called strong type checking. The most commonly used Java compilers are JavaC, JIX, and ECJ. Java Runtime Environment. The Java Runtime Environment is an important part of the JVM. The Java Runtime Environment has 3 major activities: loading code, verifying code, and executing code. The job of a JRE starts when you execute the Java application. The JRE first loads the Java class files into the memory and then uses the bytecode verifier to verify the code loaded into the memory. The JRE has another important component called JIT, or Just-in-Time Compiler, which translates the bytecodes to a CPU instruction. The JIT converts a part of the bytecode to native code, where native code refers to instruction to the underlying platform. As you see here in this picture, the bytecode is given to the JIT, which generates the native code. The JIT requires more memory because both bytecode and the corresponding native codes are in the memory at the same time. Garbage collection. Garbage collection is another important feature of JVM. Garbage collection is the process of automatically freeing objects that are no longer referred by the program. This implies that the programmer need not bother about memory management. He may focus on the business problem. The garbage collection is performed in Java by a program called Garbage Collector. This is the component of a Java virtual machine. The garbage collection is done automatically, which implies that it does not need any programmatical interference. Garbage collection may vary dynamically across JVM implementations.